recording. Screen. Okay. And yes, as was pointed out, I put 3.1, but there is no real 3.1, so we're going straight to 3.2, or I guess you could say I finished 3.1. I talked about it for less than 5 minutes, right? So we're still on to 3.2. Okay, and adjusted to 7 to 33 odd, skip 31B. All right, so the first problems I wanted to do today were the graph ones at the end, 23, 25, and 27, I think. So let's take a look at that. All right, so you're given this graph here of f of x, and it looks like it goes to -1, 2, the origin, and 1, -2, so general shape. And then what happens to all of these things? Okay, so maybe I knock off 23 through 27, all of it. Okay, so f of x minus 2. Okay, so let me go ahead and work on this. 23 f of x minus 2. So we know from before that this just shifts the graph 2 units to the right. Okay, so move 2 to the right. Okay, I'm going to make this book disappear, and I'll show you what I would do on a graph, which obviously isn't as good as the book. But all we can do is just give it the old college try, as it were. Okay, so how would I do that? Like you say, what do I do if I had this question on a quiz or test, right? So I would sort of try to duplicate this. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so I'll get the key points. The key points were the origin, -1, 2, and 1, -2. Okay, and then just kind of make it go something like this. Okay, and by the way, this is typical of polynomials. Polynomials tend to look something like this. All right, so I take the original graph and move it 2 units to the right. So maybe the easiest thing is to move these 3 key points 2 units to the right. So I'll just take this point, move it 2 to the right, and go like that. And move the origin 2 to the right, so that would be kind of like that. And move this 2 to the right, so it'd be sort of like that. And then I just try to draw the same general shape as what I had over here. So it doesn't have to be that accurate, but we'll just kind of go with it. And there we go. Okay, so if this was the original f of x, then what I have in red is f of x minus 2. By the way, in case you are wondering, no, you don't have to get different colored pens or pencils for me on quizzes or tests. You know, I do it for contrast, but if you don't want to, that's okay. In fact, I'm not even sure. Sometimes when you transmit your homework or quizzes or tests to me, I only get it in black and white anyway, so it may not even matter. But you know, I'll figure out what you did. But if you can see the blue and the red, right? So essentially, I just picked up the blue graph and moved it 2 to the right. So how do I do that? Well, just take some key points, like -1, 2, right? I just move that over 2. The origin, move that over 2. And this point 1, -2, move that over 2, and then just draw the same basic shape. Okay. So that's that. Okay, then 25 says f of x minus 2 plus 1. F of x minus 2 plus 1. Okay. Now, I just finished doing f of x minus, sorry, f of x minus 2. I may have said plus. F of x minus 2. So if you look at this and this, right now they're the same, right? And now it just says plus 1. So can you think what's the effect of the plus 1? I just take the red graph and move it 1 unit up. Okay. And the picture's going to get kind of cluttered, but I'll go ahead and do it for showing you what's happening. I'll just take the red graph and move it 1 up. Yeah, that's probably the most you feel like doing on this one graph because the picture will get cluttered. So again, I'll just take my key points. Let me see if I can pick my different colors here. Maybe I'll do green. how about these 3 points, just move them up 1. So this one just goes up 1. This one goes up 1. This one goes up 1. So 1, 2, 3. And I know it might be kind of hard to see, but you have to kind of imagine the red and the blue aren't there. Just draw the same basic shape. Okay, so this is the best I can do for that. Okay, so the green is now f of x minus 2 plus 1. Okay, and that's all I'm going to do for this particular graph because the picture is already getting kind of cluttered. So if you can follow the progression, I have the blue graph, the original function, then f of x minus 2, move the whole graph 2 to the right. So that's what the red one was, right? I moved that one 2 to the right and move the origin 2 to the right and move, what was that, 1, negative 2, 2 to the right. And then question 25, it still has that same f of x minus 2, right? So all I do is now move the whole red graph up 1. Okay, so if you can pretend the blue graph isn't there, just move the red graph up 1. So I move that one up 1, move that one up 1, move that one up 1. Okay. All right, but for the last one, 27, I'll start with a brand new graph. Okay. So 27 says f of negative x. Okay, so yeah, if you want in words here, move number 23 graph. Okay, so take the answer that you had for 23, which would have been what, the red one? Up 1 unit. Okay, so the red graph goes up 1. Move number 23's answer, the green, oh, sorry, the red one, up 1 unit to get the green. All right, now how do I graph f of negative x? Okay, so first, what does it do? Now, if the negative were out in front, if the negative was in front, you might recall that's a reflection across the x-axis. Okay. But the negative is in the inside. Maybe this will help. I mean, you're always allowed to put this on your cheat sheet. But if the minus was outside, reflect across the x-axis. What about if the negative was on the inside? You do not reflect across the x-axis. So take a wild guess as to where you reflect. You know, there's really only one other choice. You reflect across the y-axis. Right? So reflect across the y-axis. Now, how do I do that? Because there's so much stuff going on. So let me try to show you what I would do for that. So I'm going to start with a brand new graph. I'm going to try to start with the blue graph, okay? So starting all over with my blue graph. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Okay, so let me get the key points again, which were negative 1, 2, 0, 0, and 1, negative 2. Okay, and I'll just try to graph something like that. So here's the original f of x. Okay, to reflect across the y-axis, here's my suggestion. Just take them in pieces, right? So how would I reflect this across the y-axis? So you have to kind of pretend this part in quadrants 2 and 3 aren't even there. Put a mirror here. I'm going to try to get the mirror image. So I do the mirror image, and I'll pick a different color. So what are the nice colors I have here? Maybe I'll pick red. Okay, so I'm going to graph something that looks like this. So it'll end up looking kind of like a W, right? If I reflect across the y-axis, it'll go like that. Okay, I have to keep that in mind because once I see the blue graph, I might get confused. But I'm going to try to go like that. Okay, so here we go. Okay, so there's that part. Okay, now you have to pretend that red's not there. Pretend it's not there. Look only at the blue. Look only at the blue. Forget the red now. Reflect across the y-axis. I'm going to get something like this, right? So if you look only at this part, you go like that. It's kind of like a M, a funny looking M. Okay, so once I see the blue, I might get confused, but I have to make sure I remember I'm going to go something like that. Okay, so here we go. All right, and there we go. So this is f negative x, like that. And there we go. So here's f of x. Here's f of negative x. Okay. And my suggestion, if the graph goes through the y-axis, take them in pieces. So first I say to myself, okay, what's the reflection of the blue? It's going to look something like this, right? So the red. And then take this part. What's the reflection of this part? It would go up and down. So there it is, up and down. All right. Okay, next thing I want to show you is something like 31a. Okay, you can skip B. Sketch the graph of a polynomial that has zeros of multiplicity 1 at x equals 1, x equals negative 1, and x equals 2 that satisfies p of x approaches infinity. So what's this symbol mean again? So p of x approaches infinity as x approaches infinity, and p of x approaches negative infinity as x approaches negative infinity. All right, so I will lose the book, but the key things are you got a 0 at 1, negative 1, and 2. So on my x-axis at 1, negative 1, and 2, I put a dot. Okay, so here's that. Okay, x equals 1, negative 1, and 2. 1, negative 1, and 2. There, there, and there. Okay, then it says when x goes to infinity, y goes to infinity. That arrow goes to or approaches. So when x gets super big, y gets super big. That's so-called end behavior we talked about. Okay. So this is end behavior. And when x goes all the way to negative infinity, it says y goes to negative infinity. Okay, that's basically it. Okay, so you have this and this. So officially, right now we have this, the 3 dots. This side goes way out that way, and this side goes way out this way. Okay, now what about here, here, and here? Okay, I have it going up and I have it going down. Okay, all right, so here's something new. If you have multiplicity 1, which means there's no square, no cube, or anything like that, the graph will always cut across. Okay, so multiplicity 1. Multiplicity 1, the graph will cut across the x-axis. Okay, so that means right here, if this is below, this is going to be above. This is above, that means this side is going to be below. Every time you have a multiplicity of 1, it always cut across like that. So in other words, you might say, well, couldn't it come down? Okay, not if it's the multiplicity of 1. Then it'll always cut across. Likewise over here, it's on top, so it cuts across down below. And here it's below, it cuts across to become above. So whenever you have a multiplicity of 1, that means there's no square, no cube, no fourth. It'll always go something like that. Okay. All right. Okay, I'm going to go and show you 33, the last problem. And maybe I can start some of the next section, but we'll see. The cubic polynomial, so cubic means third degree, degree 3, has a 0 of multiplicity 1 at x equals 2, and a 0 of multiplicity 2 at x equals 1. Okay, so that means you have x minus 1 squared, and let's see, and x minus 2. And p of negative 1 equals 4. Determine p of x and sketch the graph. Okay, so we put down the key information. So here's key information. The zeros are x equals 2, multiplicity 1, and x equals 1, multiplicity 2. And they give you this p of negative 1 equals 4. All right, so how do I build my polynomial? Okay, temporarily ignore the k. X equals 2, multiplicity 1 means you have a factor of x minus 2. X minus 2 is there. The multiplicity of 2 means you're going to have x minus 1 squared. Okay, so one more time. X equals 2 is a 0. That means the factor is x minus 2. X equals 1 is a 0 of multiplicity 2 means x minus 1 squared. Okay, and if that bothers you, let's go backwards. Ignore the k for a moment. Okay, pretend the k is not there. If I say, what are the zeros of the function? That means what makes this expression 0? Well, 2. Okay, and 1. Okay, and we say multiplicity 2 because when I write it like this, it's really x minus 1, right? I mean, the long way to write it is x minus 2, x minus 1, x minus 1. In which case you would say, okay, x equals 2, x equals 1. Oh, there's another x equals 1, right? So I guess you could say the zeros are 2, 1, and 1, but you normally don't have to say that. So we would just say x equals 1 of multiplicity 2. Okay, now what about this k stuff? Okay, well, if k were any real number besides 0, okay, so suppose k is 1, that's the easiest, or 10, or negative 5, or 80, you would still have the same zeros. Agree? I mean, pretend right here there's an 80. The zeros would still be 2, multiplicity 1, and 1, multiplicity 2. Okay. So now, how do I find out what is the k? That's where I plug this stuff in. Okay. So the rest of the problem says p of negative 1 equals 4. That means when x equals negative 1, y equals 4. So I put 4 right here. Remember, that's the same as y equals. 4 goes here, negative 1 goes there, negative 1 goes there, and then algebraically solve for k. Right? So you can see I put negative 1 there, negative 1 minus 2, negative 1 minus 1, negative 1 minus 1 squared, and 4 on the left-hand side. In place of the p of x, put 4. Okay, then I just clean that up. So 4 equals k times negative 3 times negative 2 squared. The negative 2 squared is 4. 4 times negative 3 is negative 12. So 4 equals negative 12k. Divide both sides by negative 12, and k is equal to negative 1/3. Okay, so here's my polynomial. Negative 1/3, x minus 2, x minus 1 squared. All right, so this is the one function. Let's double check. The zeros are 2 and 1. 2 makes it 0. 1 makes it 0. And 1 we say is multiplicity 2. It's there twice. Okay. And then you can check end behavior. Okay. So what I have here is I plugged in x equals 3. And by the way, this thing is always positive, right? For anything besides 1. So I did a little sign chart. Negative 1/3 is negative. 3 minus 2, positive. This thing, since it's squared, it's automatically positive. So negative times a positive is negative. So that has to go like that. Okay. Now we have this multiplicity root. If you have a 0 of multiplicity 1, the graph will always cut across. So x equals 2 had a multiplicity of 1. So since on this side it goes down, this side it has to go up. It's not allowed to bounce down. Okay, for multiplicity 1, it goes like this. Okay, now how did I get this? You can plug in a big negative number. You don't really have to. You can plug in 0. Okay, so let's plug in x equals 0 just for fun. Okay, plug in 0. That's negative. Negative 1/3 is certainly negative, right? 0 minus 2 is negative. This thing, no matter what, is always positive. So what's a negative times a negative times a positive? Positive. So this shoots up toward positive infinity. And as you can see, so the graph is done, but when you square, you don't necessarily cut across. In fact, in this side, it stays on the same side, stays above. Okay, so for multiplicity 1, you'll cut across the graph. So if one side is positive, the other side is negative. For multiplicity 2, that doesn't seem to happen. Right, they're both on this side here. Okay. All right. Okay, now I'm going to go back and do problem 21. Yes, I know I was going out of order, but I wanted to do the graphs first. Okay, 21 is kind of like yesterday's theme. And then once I do 21, I'm pretty much done with the section, and I can get started with the next one. Okay, so draw a quick graph of x cubed plus x squared minus 2x. Okay, so I have that here. X cubed plus x squared minus 2x. So first do some factorization, as we know, right? So this factors into, take out a common factor of x parentheses x squared plus x minus 2. This factors into x times x minus 1, x plus 2. All right, so here's the original factor, the original cubic. So what are these zeros? The zeros are 0, 1, negative 2. You say, what makes this 0? 0. What makes this 0? 1. What makes this 0? Negative 2. Okay. All of multiplicity 1. So since it's all multiplicity 1, they're all going to cut across. You can see in the final answer, they all cut across. Okay, so I lay down 0, 1, and negative 2. Now I check end behavior. End behavior means after the last 0 and previous to the first 0. So way out here, way out here. So what happens when x approaches infinity? Okay, so what did I do here? I thought of plugging in 1,000,000. Okay, you're not really plugging in 1,000,000, you're just getting the sign. But the nice thing about plugging in 1,000,000 right here is you can tell they're all positive, right? 1,000,000 is positive. 1,000,000 minus 1, well, if you subtract 1 or if you add 2, that does very little, comparatively speaking. It's still a big number, right? So it's positive times positive times positive, which is positive. So on this side, it shoots out to infinity. And that actually is good enough in this case, because for the rest of the graph, these are all multiplicity 1, which means on this side it's above, it has to go down. And if this side's down, it has to go up. And if this side's up, this side has to go down. But a quick double check. I can double check by plugging in negative 1,000,000. Okay, negative 1,000,000. Negative, negative, negative. Right? It's negative 1,000,000 times negative 1,000,001 times negative 9999998. There are 3 negatives. Multiply them, you get a negative. So negative, so it goes down. So there we are. So that's the graph on that particular side. Okay. All right, so there we go, folks. I think that's all I was going to show you from 3.2 and 9:35. Okay, so I'll introduce some of 3.3, and then after a while I'll stop and let you ask questions, and if we don't have any questions, we can just stop, period. Okay, so introduction to 3.3. I've given you everything I need to for 3.2, okay? All right, so 3.3. Again, quickly, if you need the pictures for the homework again, so page 142, 3.2, some graphs, and that. And on the next page, 143. Some more, and some more. All right. Okay, so 3.3, finding factors and zeros of polynomials. Okay. They give us a quadratic formula once again. You already know that, but here it is one more time. Okay, we're going to do something called the division algorithm. Okay, polynomial long division. So I'll show you polynomial long division. You should have already seen it before in your algebra class. Okay, you may have forgotten how it goes, but I'll show you that again. Something called the division algorithm. So do you have to memorize all this? No. I wouldn't even suggest writing any of it down. You don't really need it. I mean, it's correct, it's true, there's nothing wrong with it, but you don't really need it. Okay, so let me show you the homework. Okay, so page 154. So again, those of you that are never going to get the book, make sure that yellow gets in the way. So here's the top part, and a little bit more. And then the next page, 155, it looks like. The light switches yellow on me. And 3.4. Okay, so there we go. All right, so how do we do these problems? So we have polynomial long division. Okay, remember the process of long division? Okay, so find the quotient and the remainder when the polynomial p of x is divided by the polynomial d of x. So we're doing long division. Okay, so that divided by that. Okay. So how is that done? So problem number 1, 2x squared plus 3x minus 3 divided by x minus 2. So show you the process here. 2x squared plus 3x minus 3 divided by x minus 2. Okay, so pretend you don't know any of this here. Okay, so polynomial long division, remember the process? So first you take the first thing here and the first thing here, and you ask yourself, what do you multiply this by to get that? What do you multiply x by to get 2x squared? First thing here, first thing here. Okay, so to go from x to 2x squared, you need 2x. Okay, so I put the 2x, right to 2x, and line it up in the x column. There's an x squared column, there's an x column, there's a constant column. Okay, so now you take the 2x multiplied by this whole thing. So what is 2x times x? 2x squared. 2x times negative 2, negative 4x. And then you might recall you subtract. That's how you did long division of numbers, right? So put parentheses and subtract. 2x squared minus 2x squared is nothing. You don't have to write anything. 3 minus a negative 4, that's like 3 plus 4, so 7x. Now you bring down to minus 3. That's what you did in long division of numbers, right? When you did long division of numbers, you just bring the next one down, and you start all over. Okay, so let me cover this again, so you don't see that in theory. So start once again. First thing here, first thing here. So what do I multiply x by to get 7x? What times that is that? 7. So plus 7. Now take that 7 and multiply by the original, x minus 2. 7 times x is 7x. 7 times a negative 2 is a negative 14. You notice it's all lined up. Everything here is x squared. Everything here is x. Everything here is a number. All right, so parentheses, subtract. 7x minus 7x is nothing. You have to be careful because there's a lot of double negatives here. Negative 3 minus a negative 14, that's like negative 3 plus 14, which is a positive 11. Right, so my remainder is 11, and here's how you write it. Plus 11 over x minus 2. That is kind of how you did it with long division of numbers, right? You have a remainder. So maybe the first time you learn long division, right, you put R11. Remember doing that in grade school? Put R11. Then you got fancier and you put 11 over the divisor. Okay, so here it is, 11 over the divisor. One other key thing, though, is you're supposed to put a plus. Okay, so remainder, 11 over the original divisor, x minus 2. Put a plus. Okay. You actually have an option if this comes out to be a negative. Suppose it was negative 11. You can put the negative here and then 11. Or you can put plus and then negative 11. Okay. Quick word, when you're doing long division of numbers, like suppose you had 5 and 1/2, right? When you write 5 and a half, everybody knows it means 5 plus a half. Nobody thinks of it as 5 times a half. Not so in algebra, right? Once you start throwing in symbols, if you don't put the plus sign, right? Suppose you only write it like this. Then the understanding is that means multiplication. Because once I see all these x's, then you would say, oh, I'm doing algebra. And if I don't see a symbol, it means multiplication. So now if there's a remainder, you must put the plus. Or you can put a minus if it turns out to be a negative remainder. Like I said, I'll show you examples of that. So you can't just leave it like this. I would take off if you just leave it like that. 2x plus 7, 11 over x minus 2, like you did with an answer that came up to be 5.5, right? You don't have to write 5 plus a half because everybody knows it's 5.5. It doesn't mean 5 times a half. But in an algebra context, right, if you leave it like that, and I see all these x's and stuff, then people will say, oh, we're doing algebra. So if I don't have any symbol, it must mean multiplication. So you must put the plus in the remainder. All right, so there it is. Okay, so a quick review of that process once again. Okay, so the thing that you're dividing by goes on the inside. And the thing that's being divided is on the outside, right? So that over that, sometimes we say it's that divided by that, that's on the inside, that's on the outside. Okay, then you take the first thing here, x, the first thing here, and you say, what do you multiply x by to get 2x squared? 2x. So the 2x goes on top. I put it in the x column. Everything here is x. Everything here is 2x squared. Everything here is a number. Okay. Now you take that 2x times this whole thing. So 2x times x, 2x squared. 2x times negative 2, negative 4x. Parentheses, subtract. That minus that is nothing. 3x minus a minus 4x, that's like plus, so 7x. Bring down to negative 3, start all over. Okay, pretend that's not there. How do you go from x to 7x? You multiply by 7. Now 7 times the whole thing. 7 times x is 7x. 7 times negative 2 is negative 14. Subtract, negative parentheses. 7x minus 7x is nothing. Negative 3 minus a negative 14 is 11. So plus remainder over divisor. Okay. Okay, I'll show you a couple more, and then maybe that's about it. Okay, 3. P of x, x cubed plus x squared minus 2. The divisor is x minus 1. All right, now there's something special about the way I do this. This goes from x cubed to x squared. There's no x, and then it jumps to negative 2. Look at the way we have to set it up. Okay, if there's no x term, you count it as a 0x. We have to have a column for, if you start with x cubed, you must have x squared, you must have x, you must have number. So if anything's missing, count it as a 0 coefficient. So notice the way I wrote it, x cubed plus x squared plus 0x minus 2. In case you're wondering, you say, do I have to write it? Yes, you have to write it. If you don't write it, you'll get things fouled up. Everything won't match exactly. Okay. And then after that, you just do the same thing. Okay. In fact, suppose it just went from x cubed down to negative 2, straight from x cubed to negative 2, then you would have to put 0x squared, 0x, and then the minus 2. All right, after that, we do the same thing. Okay, first thing, x, x cubed. What do you multiply x by to get x cubed? X squared. Put the x squared on top. Now you take x squared times this whole thing. So x squared times x is x cubed. X squared times negative 1 is negative x squared. Subtract. That minus that is nothing. X squared minus a negative x squared. Be careful, this is not 0. Remember, you're subtracting. So x squared minus a negative x squared, right? So that's like plus. So 2x squared. Bring down to 0x. In case you're wondering, you say, do I bring down to 0x? Yes, and again, think by analogy, what did you do for long division of numbers? When you did long division of numbers, if there was a 0, did you bring it down? Yeah, you still brought it down and kept going, right? So just do the same thing. All right, start over. First thing here, first thing here, first thing here, first thing here. What do you multiply this by to get 2x squared? 2x. So plus 2x. Now you take 2x times this whole thing. 2x times x is 2x squared. 2x times negative 1 is a negative 2x. Subtract. That's gone. 0 minus a negative 2 is a positive 2x. Bring down to negative 2. You just keep going until you run out. Just like when you did long division of numbers, right? When you did long division of numbers, you just keep going until you run out of stuff. And start once again. How do you go from here to here? Right? So from x to 2x, multiply by 2, so plus 2. Now take 2 times this whole thing, 2 times x, 2x. 2 times -1, -2. Subtract, well, anything minus itself is 0. So here's a case where we have no remainder, which is fine. No remainder, don't put it. That's what you did in long division of numbers, right? If there's no remainder, just stop and leave it alone. So here it's plus blah, 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 but not here. Here we're finished. Okay, then number 5, and I think maybe that'll be just about it. What time is it? Maybe 10 to. So let's stop with this. Okay, so they give me something longer here. So P of x is this long thing, and D of x is this thing. All right, so 2x to the 4th, x cubed, x squared, x, and number. So nothing's missing. X squared, x, and number. So nothing's missing here. So I'd have to include a 0 like I did for the previous problem. So here it is. 2x to the 4th minus 2x cubed plus 4x squared plus x minus 2. Divided by x squared minus x minus 1. So I don't have to include that 0 thing like I did over here, right? Over here there was no x, so I had to sneak in a 0x. But here it's all there. If I start with x to the 4th, I must have x cubed, x squared, x, and a number. And if anything's missing, put it as a 0 coefficient, but they're all there. Likewise here, x squared, I've got to have x and a number, they're all there. So it's perfect. Okay, so same thing. First thing here, look at only these two. What do you multiply this by to get that? So how do I go from x squared to 2x to the 4th? You need 2x squared. So I put a 2x squared on top. Now take 2x squared times this whole thing. So 2x squared times x squared is 2x to the 4th. 2x squared times negative x is negative 2x cubed. 2x squared times a -1 is a negative 2x squared. Subtract, parentheses. That minus that is 0, don't have to write it. That minus that is also 0, don't have to write it. It's negative 2x squared, negative 2x cubed minus a minus, which means plus 2x cubed, so they will cancel out. And watch out, this is also a double negative. So 4 minus a minus 2 is 6. So 6x squared, bring the rest of the stuff down, plus x minus 2. And start all over again. Okay. For your final answer, you don't have to put a 0x because that's normally what we don't do that for final answer. So you shouldn't have to put plus 0x. Just for the answer, just go 2x squared plus blah, blah, blah. Okay, so how do you go from here to here? X squared, 6x squared, multiplied by 6. So plus 6. Now you take 6 times this whole thing. 6 times x squared, 6x squared. 6 times negative x, negative 6x. 6 times -1, negative 6. Put my parentheses, subtract. So that's gone. You have to watch out, there's a lot of double negatives. X minus a minus 6x. So that's like x plus 6x, which is 7x. -2 minus a negative 6. -2 plus 6, 4. And that whole thing is my remainder. Okay, so plus 7x plus 4 all over x squared minus x minus 1. And that's my answer. That's my remainder that I have right there. Okay. So that's pretty much about it. I will say one more thing. I'm going to say it again tomorrow, but it'll just make things a little bit easier since I have about 8 minutes left or whatever. Okay. So something about going back to problem number 1. Okay, so look back at problem number 1. It came out to be this, right? 2x squared plus 3x minus 3. That was the so-called P of x, my polynomial. And D, the divisor, is x minus 2. What happens if I plug in 2? Okay, so seemingly unrelated. Plug in 2. Where did I get the 2 from? Because this was x minus 2. Okay, 2 times 2 squared plus 3 times 2 minus 3. 2 times 2 squared, 2 times 4 is 8, plus 3 times 2 is 6, minus 3. 14 minus 3 is 11. Okay. Notice something about that 11? That happens to be the remainder over here. Notice that? It's 11. Let's try over here, problem 3. I was dividing by x minus 1. By the way, what was the remainder for number 3? Looks like the remainder was 0. What is p of 1? That means what happens when you plug in 1 to this problem? 1 cubed plus 1 squared minus 2. 1 cubed is 1. 1 squared is 1. 1 plus 1 minus 2 equals 0. I get the same value as the remainder. That will always turn out to happen. Okay, that's going to be something called the remainder theorem. Okay, I'll just show it to you quickly, but you don't have to worry about it now. We'll talk more about it tomorrow. But quickly, the remainder theorem. When you do a polynomial and divide by x minus a, like we did here, the remainder is always the same as p of a. Okay, so if you want just the remainder, back over here, you could do the polynomial long division. Or the remainder is whatever you get when you plug in 2. Plug in 2 there and there and there. It'll come out to be 11. Likewise, over here, I did the long division. The remainder was 0. Or we could have just plugged in 1. We got that from x minus 1. If you plug in 1, you also get 0. Okay, I'll talk more about that tomorrow. So let me stop the share. And that will do it for today. Okay, and let me check the chats. There's nothing in the chat. All right, so does anybody have any quick questions or remarks about anything? If not, we can just stop. That's the way it generally would be. So if you got nothing else, I got nothing else. We can just call it a day. Okay. Let's see, question about graphs in the exam. Yeah, you will certainly have some graphs in the exam, possibly. Everything that was on the homework is fair game, right, in terms of what's happening on exams. Okay. You have to show it like I did, yes, in general. It's always a good idea to do things the way the teacher wants. I mean, I'm not just talking about my class, all your classes in general, right? However the teacher wants it, do it that way. Obviously, that's the way that they want it. Good. Okay, could I use the remainder theorem for number 5? Yeah, and I was going to show you that tomorrow, so that would certainly be fine. Okay. All right, anything else, please? Okay, that'll do it for today, folks. All right, so yeah, the remainder theorem can be used to check your work, and we'll do some of that tomorrow also. Okay. All right, that'll do it for today, folks. So have a good day, and we'll see you all tomorrow. Okay, bye, everyone.